Okay, let's check answers for try number 1A and B. So first, you want to rewrite them in matrix form. So your augmented matrix for part A should be 2, -5, and then dot, 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 11. And then your second row would be 4, 3, and 9, right? And then you solve your matrices, your matrix one by one. I'm going to multiply 2 on the first row, and you have 4, -10, and 22. 4, 3, 9 is the same second row, and then we're gonna subtract them, and then I'm gonna put the subtraction on the first row, or I'll do it on the second row. Yeah, so that I have 0 on the second row, and then -13 on the second column, and then 13. If I subtract these two and then put it on the second row. And then the first row, I'm gonna divide it by 4 to get 1. And then -10 divided by 4, 22 divided by 4. It's a fraction, so I'm gonna go back and just rewrite the original one. 4, -10, and 22. Okay, and then I want to make this 1, right? And then I want to make that 1 and this 0. So first, I'm gonna divide this by 13. So I have 4, -10, 22 divided by 13, the second row, and then I have -1. Or I'm gonna just straightforward divide it by -13, and then so that I have +1. Okay, and then divide this by -13, and I get -1, right? So just remember to put the correct signs, and then I'm gonna move here for part A. And then now that I have 0, 1, I want 1, 0 on the top row, right? So I'm going to I'm going to make sure that I can cancel the second row. So I'm going to make the second row by 10. I'm going to multiply by 10 so that I can cancel out the first row. So I already have 0, 1, -1, and I can easily come back to that. So multiply by 10 to get 10 and -10 on the bottom. And I'm just going to simply add them. So I have 4. If I add 4 and 0, it's just still 4. And then I add them, it's 0. I add these two, I get 12. And then the second row, I'm just going to divide by 10 again to get 0, 1, -1. Okay, and now I can just divide the first row by 4 to get 1, 0, 3. And now I have 1, 0 on top and 0, 1 on the second row, right? And this is our final answer. So I'm going to write the final answer as 3, -1. Whoops. I'm gonna make sure that's in the box. Okay, good. If you've done different way, maybe you have more steps or less step, but you should still be able to get the same answer. If not, please check your steps again. So that's why it's really important to write all the matrices so that you can catch where you messed up. Okay. All right, part B. I'm also gonna reduce the matrix, write the augmented matrix, and write it in the row echelon form, which is the reduced form. Okay, so the part B the augmented matrix for part B would be, I'm going to divide this section so that it's easier to see, would be 3, -4, and -18. And then -4, 8, and 32, right? They're already in standard form. And then you can multiply the first row by 2. And I have 6, -8, and -36. And the same second row. And then I'm just going to add them so that the second row cancels out. And because that's 0, I want 1, 0, right? So I'm going to put that in the first row. So I have 2, 0, and then -4. And then I'm going to divide the second row by 2 and get -2, 4, and 16. And now I can add these two to get 0 on the first column here. So, and then I'm going to put it in the second row, right? So I'm getting closer to the row echelon form. So the first row is still the same. But the second row, if I add these two, I'll get 0, 4, and 12, right? And then I'm going to divide the first row by 2, so the second row by 4 to get 1, 0, -2, and 0, 1, 3. Easy. And so the final answer should be -2, 3. Good. So check your answer, see if you got it right. If not, please go back to your steps and see which step you forgot to add or subtract or multiply or divide the right numbers. Sometimes it's easy to make mistake to do the operations for the left side of your dotted line. I make that mistake a lot. So look for simple mistakes like that. All right, we're gonna move on to example 2. Solve linear system of equations using matrices. So we already talked about reduced row echelon form a little bit. This is when we have 1 and zeros in the correct format, so we can look at the answer right away. So the reduced row echelon form is the last step of your matrix when solving systems of equations using matrix. So if you have 1, 0, 0, a as a constant, then we know the first variable will be equal to the constant a. And in the same way, 0, 1, 0 will give you second variable equal to your other constant b. And then the last variable, 0, 0, 1, would be your constant c. So this is what we want when we have 3 variables, x, y, z. Okay, so let's look at 3 variable matrix. So here, as an example, we start with 1, 1, 2, 13, 0, 2, 1, 5, 2, -1, 0, 6 as our system of equations. Our final goal is to have the reduced row echelon form in this form. So we want to make zeros and 1. So first we want to multiply and add each row to get zeros. So here we already have 1 and 0. We want to make the last column 0 as well. So first we're going to multiply the first row by 2 to get 2, 2, 4, 26. And then we're gonna subtract the third row by the first row times 2. So then we have 2 minus 2, 0, -1 minus 2, -3, 0 minus 4, -4, 6 minus 13 is -13. I think there needs to be -6 here. I think they're talking about -6. Yeah. So then yeah, negative 6 minus 13 is negative 6. Oh, sorry. No, never mind. Sorry, I was confused. So 26 minus 6 minus 26 would be negative 20. Okay, there we go. Yeah, it's really easy to make mistakes when we don't write the entire matrix like that. And then we're going to add the second row, the new third row, and the second row times 4. So the second row, we're going to times 4 to get 0, 8, 4, and then 5 times 4, 20. And we're going to add this and the new third row in order to get rid of the last row, the last column, right? So 0, 5, 8 minus 3, 5, and then 4 minus 4, 0, 20, 20 minus 20, 0. We're adding these two, okay? And then we have 5, and you can just divide this by 5 to get 1. And now we have 0, 1, 0 here, and that's equal to 0. We can move this, we can switch this row with the second row so that we have 0, 1, 0 on the second row. That's what we want, right? Now we have 1, 0, 0 in the first column and 0, 1, 0 in the second row, and we're getting closer. We do the same operations, similar operations. We're going to multiply the second row by 2. Now that we have 0, 1, 0 here, it's really easy to control the other ones because we can make anything with this 0, 1, 0 without even changing the 0, because anything multiplied by 0 is 0, right? So we can change this number in order to add and subtract with the first and third row and get rid of our 1s and 2s, right? So this times 2 and add times negative 2 and adding it by the third row, we can get 0, 0, negative 1, negative 5. And then again, the second row times negative 1, and then adding the first row will give us 1, 0, 2, 13, 0, 1, 0, 0, right? And 0, 0, 1, 5. And now the last one, we can use the third row because that's 0, 0, 1. We can multiply by negative 2 and add the first and third row in order to get our last matrix. 1, 0, 0, 3, 0, 1, 0, 0, 0, 0, 1, 5. And now that's our final solution. 3, 0, 5. Our x is 3, y is 0, z is 5. There we go. Okay, so in order to check your answer, you can always plug in your numbers for your variable into your original equation. So you had 3 different equations in the beginning, right? So if you plug in all these numbers, 3, 0, and 5 into each of these equations, you should get the same answers. 13 equals 13, that's the true statement. 5 equals 5, true statement. 6 equals 6, true statement. So this is just to check your answers. And then you can verify that the solution is 3, 0, and 5. All right, let's try 2A and B's. Pause the video, see if you can figure it out by yourself. Write all the matrices in your steps and see if you can figure out the correct answer. Come back when you're ready for answers. Okay, are you ready? So you're first gonna write the augmented matrix, and then you're gonna write the matrix in reduced row echelon form to solve. So what's your first augmented matrix when you convert this system of equation for part A? You see 1, 1, 1, 13, and then there's no x on the second equation, so 0, 1, negative 1, 3. And then there is x here, but you have to move this so that you can have the correct form. So if you write this into standard form, you'll get negative 2x plus z equals 0, right? So your augmented matrix for part A, I'm gonna write the steps here. So part 2A. You're gonna start with 1, 1, 1, 13, and then 0, 1, negative 1, 3, and negative 2, 0, 1, 0. Okay? And then you can multiply the first row by 2 in order to get 2, 2, 2, 26. And then you can add the first row and the third row, and then you can put it in the third row, so that the 0 you want it in the third row, right? So then so these two, add them together, it's gonna be on the third row. So 0, 2, 3, 26 would be your new third row. And then the first row, you can divide it by 2 again to go back to your original 1, 1, 1, 13. Then your second row stays the same. Okay, and now what can we do next? We have 1, 0, 0 in the first column. We're getting closer and closer. After that, you can multiply the second row by 2 in order to add these two and get rid of it. Or you can multiply by negative 2 and add them, okay? So the second row, we're gonna multiply by negative 2. 0, negative 2, and then positive 2, negative 6. And then 0, 2, 3, 26. And then we can add these two, the second and third row, in order to get your third row. So you have 0, 0, 5, and 20. Okay, and then your second row, you can divide it by negative 2 again to go back to your original row. Okay, and then I'm gonna continue over here. After that, you can what can you do? The second row, you want this to be 0, right? The last column to be 0. So your second row could be multiplied by 5. And then you can add these two, right? So 1, 1, 1, 13, 0, 5, negative 5, 15, 0, 0, 5, 20, right? And then you can add these two. So 1, 1, 1, 13. And then you can put it in the second row. 0, 5, 0, and then 35. 0, 0, 5, 20. And then you can multiply these two by 5, right? And then you have 0, 1, 0, 7, 0, 0, 1, 4. And now you can multiply the second and third row by any number, or you can just subtract it from the first row in order to get 1, 0, 0, 2, because 13 minus 7, 13 minus 4 would just give you 2, right? So I'm skipping one step, but I'm subtracting the first row by second and the third row at the same time. Okay? So then your final answer should be 2, 7, and 4. So 2A, your final answer, 2, 7, and 4. But your question said write the matrix in reduced row echelon form. So your final answer could also be this. Okay, you can stop right there. In the same way, part B, you're gonna do the same thing, but you're not going to get a pretty integer. For part B, you will get a fraction or a decimal. So let's look at part B. The augmented matrix for part B would be 1, negative 1, 1, 5, 4, 0, negative 1, 3, and 0, 1, 0, negative 1, looking at your system of equations, right? Yeah, so here you're going to start with, you can start with switching the second and third row so that you can get 0, 1, 0. 0, 1, 0, your y is already solved for, right? So you can just switch these rows. 1, negative 1, 1, 5, 0, 1, 0, negative 1, and 4, negative 1, 3. 4, 0, negative 1, 3. Whoops. Okay, and now that you have solved the second row already, you just need to solve for the first row and the third row, right? So the first row, you can add the first row and the second row so that you can get rid of the second column in your first row. So we're going to add the first and second row to rewrite the first row. So 1 plus 0, 1. Negative 1 plus 1, 0. 1 plus 0, 1. 5 plus negative 1, 4. Right? And then you have 0, 1, 0, negative 1. 4, 0, negative 1, 3 here. Okay. And then, what next? We want to make this 0, and we want to make this 1. We want to make that 0. So first, we can add the first row and the third row, so we can get 0 over here, right? Yeah. And then we can replace the first row by doing so. So 1 plus 4, 5. 0 plus 0, 0. 1 plus negative 1, 0. Good. And now 4 plus 3 would be 7. And then 0, 1, 0, negative 1. And then 4, 0, negative 1 is 3. And now what else can we do? We can divide the first row by 5 to get 1, 0, 0, right? 1, 0, 0. Divide by 5, you get 7 divided by 5. And then second row is solved. So first row and second row are solved. And then lastly, the third row, you want to get rid of the 4. So first, let's rewrite this. And now in order to get rid of that, you can use the first row. You can multiply the first row by 4 and then, or negative 4 and add them, right? So the first row could be changed to negative 4, 0, 0. And then negative 28 divided by 5, right? 0, 1, 0, negative 1, 4, 0, negative 1, 3. And then you can add them. So that's 0, 4 plus negative 4, and then 0, and then negative 1. And then that's going to be negative 13 over 5. Okay. And then you can change the first row again back to 1, 0, 0, 7 over 5. And second one, you can just rewrite it. But yeah, you're not going to get a pretty whole number, and that's okay. Your x is 7 over 5. Oh, we're not done, right? We just need to multiply the last row by negative 1. So 0, 0, positive 1, and positive 13 over 5. Good, now we're done. So we have x is equal to 7 over 5. Y is negative 1. And z is 13 over 5. Or you can write them into decimal. If you write it into decimal, you'll get 1.4, negative 1, 2.6. Okay?